Hello, you've reached episode 10 of the podcast series, The Question of God. Has our civilization outgrown God? My name is Sophie Minerva. I'm a professor of philosophy at NLA University College in Oslo. This podcast series is the result of a pedagogical experiment I conducted last year, and 12 episodes have been made. The recording you're listening to is from cafe conversations I had with 4 students with different views about questions related to God. Our starting point was the book Outgrowing God by the well-known atheist Richard Dawkins. The theme this time is the concept of design and how this can be defined. How do we recognize design? And how does design relate to evolution? Now, let's join the conversation in the cafe. Hello, everyone. Astrid is unfortunately unable to come to our discussion today, but she says she'll join us next time. Okay, Douglas, you have prepared an introduction. Are you ready to start? Good. Please go ahead.
Right. Dawkins touches on an important concept in identifying design. The concept is often called specified complexity. He doesn't use the term directly, but he describes the phenomenon using the famous clock example that the theist William Paley used to describe what design is. Paley said that if you find a stone on the ground, it could be explained by chance. If you find a watch, it couldn't be explained by chance. Watches don't just happen by chance. So Dawkins writes that if you take a watch apart and randomly mix it up 1,000 times, you will only get 1,000 piles of watch parts. None of these piles will be able to tell time. This is the main difference between a watch and a stone, he says. Both objects are improbable in that they are one unique combination of their parts out of many possible combinations of their parts. But the watch is unique in a more interesting way. It tells time. Of all the many ways that the watch parts could have been put together, there is only one way, or only a very few, that will fulfill its specific purpose. Okay? So a watch is a complex and functionally specific arrangement of parts. The thing is, biological systems both have a specific function and appear to be very complex.
And that means they are designed. Is that what you say?
Well, Thomas, organic life needs a certain functional specificity in order to work. That's a fact. The question is, how complex, how improbable is this functional specificity? How unlikely is it for these systems to have happened by chance? The probability of an event must be assessed in relation to the resources available, right? If you toss 10 coins in the air, there's only a small chance that all 10 will come up heads. But if you have 1,000 tries, there's a high probability that all 10 will come up heads at least once. In the second example, the resources available to chance have been multiplied by 1,000. So if a chance explanation for a specified event or pattern remains highly unlikely after all the relevant resources for chance have been taken into account, then you are dealing with specified complexity. Specified complexity is a signature of design. It's like the definition of design.
But things can look designed without being designed, right?
Well, what about recognition of design? How can we know if something is designed? Well, we know it when we see it. We make, generally, reliable, intuitive judgments about things being designed all the time, like noticing the difference between a stone and a watch. Another example. If you're walking alone on the beach and you see a heart carved into the sand, you immediately conclude that someone drew it, right? Not that the sea did it.
A heart in the sand. Oh, that's nice, Douglas.
Yeah, I can be pretty romantic.
I'm sure you can, when you put your heart to it.
Sorry, did you finish your introduction, Douglas?
No, not quite. So, when we make an intuitive judgment about the watch or the heart in the sand being the product of design, what we are recognizing is that these things exhibit specified complexity. Knowing this, we can make judgments about design that are explicit rather than intuitive. Now, Dawkins accepts that specified complexity indicates design, and he doesn't deny that functionally specified structures exist in nature, or that those structures are highly unlikely to have emerged by chance all at once. But he maintains that nature could have created such structures by itself, gradually, mutation by mutation. in a series of steps where each step needs to pass through the filter of natural selection. His conclusion is that evolution by natural selection, that is bottom-up design, is a better explanation than top-down design, as he calls it. I'm sure we will discuss that. Okay, that's my introduction, Professor.
Thank you, Douglas. Very good. Yes, Hiromi?
This has been a very interesting topic for me to consider. An eye-opener, actually. As I understand him, Dawkins thinks the impression of design is a delusion. He believes the functionally specified structures so typical of biology can arise by chance, or by the gradual accumulation of genetic variations over long periods of time, as he would say. But he provides no concrete evidence for this claim. Cells are like automated factories, and they are full of biological machines, right? I mean, just watch animations about cellular machines on YouTube. They are breathtaking.
Yeah, okay. They look designed. But as Douglas points out, the available resources for chance is clearly the key issue here, isn't it? We're talking about millions of years. Dawkins writes that, quote, "Since our ancestors were fish crawling out of the sea, 3 million centuries have passed. That's an awful lot of time. An enormous opportunity for change, step by step down the generations," unquote. 3 million centuries, Hiromi. Did you get that? That's 300 million years.
Yes, Thomas, I realize that. But Dawkins produces not even a sketch of a calculation of how many opportunities for change 3 million centuries actually provides. Several scientists have argued that these resources are far too limited to make it plausible that functionally specified biological structures at this level of complexity can be constructed by unguided natural processes. And Dawkins offers no concrete statistical explanation of how these biological machines arise. He just makes a huge leap from being able to imagine that something like that might have happened in 3 million centuries to simply assuming it did happen. I was amazed when I realized that. The argument seems suddenly so thin.
Wow, Hiromi, you are growing more skeptical every week. Where is this going to end?
Wherever the evidence leads, Thomas, wherever it leads. So what Dawkins underestimates, I think, is the astronomical improbabilities for chance.
But evolution is common knowledge, isn't it? Populations of species are shifting steadily, all the time. Think about this. It only took a few centuries for a wolf to become a poodle. Imagine how much can change in a million centuries. That's what Dawkins says. It makes a lot of sense, right?
It's too simple, Thomas. A poodle is still a canine, right? And actually, it is a result of guided evolution, not unguided. The poodle is artificially bred. Do you know any evidence showing that unguided evolution can change a wolf into a non-canine animal?
But those animals exist, so it must have happened, right?
No, Thomas. The mere fact that animals exist only shows that there must be some explanation or other of their existence. It doesn't show which explanation is true. To simply privilege the explanation you prefer is an exercise in begging the question, rather than arguing for your conclusion.
Okay, fair enough. But evolution by natural selection could explain the animals we see around us, right?
I think Dawkins makes a mistake when he appeals to our imagination and ignores the statistical evidence. Dawkins is essentially asking us to believe that blind natural processes can do everything. That's much more than turning a wolf into a poodle. Evolution is supposed to start with some sort of primordial, unicellular life form, right? And then this unguided process eventually ends up constructing humans. This means developing new genes, new cellular machines, new cell types, new animal body plans. In other words, a whole bunch of new biological information. Isn't that a big elephant to swallow, statistically speaking? Mathematical calculations indicate that the universe does not have enough elementary particles and has not existed for enough seconds for a minimally functional cell or even a functional protein of modest length to arise by chance.
Well, I think Hiromi has a valid point, if we only take into account the universe that we observe about us. But maybe the resources available to evolution go beyond the universe we know? Maybe there are other life-permitting universes like our own.
That's a big maybe.
Well, you can't rule it out. It's not self-contradictory.
Goodness, I thought Darwin had settled the debate about design, but here's Douglas defending Darwin by clinging to the existence of multiple unobserved universes, which sounds like a gap theory.
What's wrong with it? What's the alternative? God?
Oh no. Does it really come down to this, God, or wild fantasies? That is depressing.
Why? Why would the God alternative be so terrible?
Now, wait a minute here. We are talking about complexity, right? What about crystals? They're not living things, but they form complex patterns all by themselves. And in chemistry, there are complex processes going on all the time that run by themselves, right? They are ingrained in the stuff itself, aren't they?
I'm sorry, Thomas, but you're barking up the wrong tree. Yes, crystals and chemical reactions are patterns inherent in the properties of substances. However, those patterns are not complex, whereas life is complex. There is a fundamental difference here, precisely because the specific structure of a crystal is inherent in the stuff that forms it. Crystals are actually simple, rather than complex. When a crystal grows in its characteristic pattern, that's not an unlikely outcome. It's predictable. Can you see that?
If crystals are specified, non-complex structures, then I suppose the opposite are unspecified and complex structures, like clouds of smoke, right?
Hey, there are exceptions to that too. I mean, specified smoke. You can send smoke signals, right?
You're hilarious.
Let me add something here about chance and design. You are discussing a very, very old issue. The Roman politician, philosopher, and writer Cicero, who lived more than 2,000 years ago, was thinking about chance and design. He asked the question, if you took a large number of letters from the Greek alphabet, mixed them in a jar, and scattered them on the ground, would it ever produce a poem by Ennius? He said, quote, I doubt if chance could have produced a single verse, unquote.
That's a great example, Professor. It's like Scrabble, isn't it? If I pour the tiles out of a bag, I can get letters in a sequence. But do they form sentences? You could say that the letters form a complex chain of information, but it's only when they form meaningful words and sentences that the information is specified.
Yes, that's correct. The same could be said about programming computers. It is specified complexity that make a computer program function. The discovery of DNA coding has shown that information lies at the heart of biology. Computer programs use binary code, zeros and ones. DNA uses a 4-digit chemical code. They call them A, T, C, and G.
I read about this. Bill Gates, the Microsoft founder, said that DNA programming is more advanced than humans have been able to master. This was a shocking statement for me. I never knew this.
I know what you mean, Hiromi. But Dawkins also writes about this. He says, quote, what happened over all those billions of years of evolution was that the DNA instructions for how to make babies were gradually built up by natural selection, unquote. Are you denying, Hiromi, that nature could have organized these codes through natural selection, even if it had billions of years to do it?
Well, it is not just the codes, is it? Think of all the machinery needed to make use of them. The codes function as part of a complex functional system. And natural selection doesn't bridge the gap because natural selection can only act once something functional turns up. I saw a comment from the astronomer Sir Fred Hoyle where he said that when you look at the universe and biology and the way everything is so finely tuned, common sense tells you that some super intelligence has tampered with physics, chemistry, and biology, and that there are no blind forces in the universe worth talking about. And, by the way, he was an atheist.
Yeah, Hiromi. And if the available resources for chance is limited to only our universe, Hoyle is surely correct. But, again, a multiverse opens a new world of opportunities, doesn't it?
But I cannot see how this will explain anything. Isn't the multiverse idea the ultimate non-explainer? Is there any evidence for design that you could not just explain away by invoking other universes? I mean, any human design could also be explained away by appealing to the multiverse, right? Should archaeologists reject the design as an explanation for anything they dig up because in a multiverse anything could happen by chance?
Fair enough, Hiromi. It's a reasonable objection, but perhaps there are only a few universes in which intelligent life has evolved. In that case, the multiverse could explain life without explaining away human designs.
That seems like an awfully convenient sort of multiverse.
Well, I'm not convinced about multiverses. I'd rather stick with the universe we can see. I think Dawkins is right. I think he is explaining the appearance of design in biology by the process of evolution. It makes sense to me. But of course, the fact that Douglas feels the need to appeal to other unknown universes makes me think. I wonder if maybe design is more of a live question than I had thought.
From what I've read, Thomas, design is very much a live question. I also want to mention the phenomenon called irreducible complexity. As I mentioned last time, I have been reading the American microbiologist Michael Behe. He uses that term, irreducible complexity, to describe complex, functionally specified machines inside cells. He points out that these machines don't perform their functions unless they have all their parts in place and working together. That's what he means by calling them irreducibly complex. This fact undermines the Darwinian idea of gradually evolving systems from simplicity to complexity. You see?
Not yet, Hiromi. Go on.
The thing is that if parts are missing from an irreducibly complex machine, it doesn't just work less well, it doesn't work at all. And a non-working system offers nothing for natural selection to select. Can you see that? It doesn't improve survival. And remember, there is no planning ahead in evolution. Every natural process is blind and unguided, right? So the point here is, natural selection cannot build an irreducibly complex machine, which we find inside living cells through a direct sequence of evolutionary steps. The machine would not work until it was complete. But it is highly unlikely that such a machine could form all at once or by any indirect sequence of steps, each of which had a selectable advantage. I actually find this very convincing. I'm really amazed to learn about this.
Perhaps it would be useful to consider a concrete example of the sort of biological nanomachinery you are talking about, Hiromi. Can you give us an example to think about?
Yeah, sure, Professor. There are many examples. One such nanomachine that Michael Behe discusses is called the bacterial flagellum. It's actually a tiny outboard motor that some bacteria use to move around. I have some facts here. Listen to this. The propeller is shaped like a whip and can spin 100,000 times a minute. It's built up by around 50 parts. The power comes from a very efficient acid-fueled motor with a drive shaft, a stator, bushings, O-rings, and so on. Can you imagine how unguided evolution could randomly construct a system like this, step by step? And Cells features hundreds of systems like this, working together in an integrated way.
Okay, well, I agree that it certainly looks designed. But I've read that the bacterial flagellum doesn't really prove anything because you can find some similar components in other organs. I guess biological system parts can randomly click together, sort of. Strange things happen, right?
That's rather like saying that because you can find parts of a complete engine laying around a scrapyard, it's not unthinkable that a complete working engine could come together without any intelligence being involved. Come on, Thomas, isn't that an example of blind faith?
Hiromi has a point. The atheist philosopher Daniel Dennett admitted that Darwinism, quote, is a purely theory-driven explanation, argued from the assumption that natural selection tells the true story, some true story or other, about every curious feature of the biosphere. It assumes that Darwinism is basically on the right track, unquote. I think it is not unreasonable to doubt this assumption, and I say this even though it's one I make myself, but on philosophical grounds. Let me give another example. Actually, another atheist and Nobel laureate in physics, Brian Josephson, observes that Dawkins assumes there is a continuous path from the origin of life to man, with each step along the path small enough to have occurred by chance, given the available resources for chance. Given his naturalistic worldview, it is thus a logical necessity that such a path should exist. But that's a philosophical assumption, not a scientifically verified theory. In other words, Darwinist evolution only serves as an explanatory model for those who already believe in a naturalistic worldview, like I do. Do you see my point?
Douglas, you're the strangest atheist I've ever met. Didn't you just cut off the branch you're sitting on?
No, not at all. Like Josephson, I simply have no sympathy for ideological scientism. Science shouldn't be used to promote naturalistic propaganda. Are you worried about your atheism, Thomas? Remember, if enough other spatial regions besides our visible universe exist, it means it's not too complex to attribute to chance. Atheist biologist Eugene Koonin also appeals to multiple universes to increase the resources available to a chance-based explanation of life. He argues that to get an undesigned origin of life, then a vast number of spatial regions like our visible universe is a must.
This is a good discussion. It is interesting to listen to you, but let me ask you a question. You seem to agree that there are valid arguments against Darwinism, or at least genuine issues with the theory, although you disagree about how to resolve these issues. Hiromi says she has been surprised to learn about the problems with Darwinism. Why do you think that many people are unaware of these problems?
I think it is far too much prestige invested in the classical evolutionary story. Most of its defenders will never back down, but some scientists are willing to acknowledge these problems and look for answers.
Douglas, you amaze me. Darwinist defenders who will never back down? I never thought I would hear such conspiracy theories coming from you.
I read about several specialists who say that the neo-Darwinian theory is an inadequate explanation of the data. One of these, Gunther Tyson, who holds the chair of genetics at Friedrich Schiller University of Jena, says, quote, "Despite Darwin's undeniable merits, explaining how the enormous complexity and diversity of living beings on our planet originated remains one of the greatest challenges of biology," unquote. In other words, he says, we don't know.
Okay, everyone. This has been a good discussion, but time is up for now. We have talked about design today, but we have also touched on the topic multiverses. The idea of multiple universes is something Dawkins writes about in chapter 12 of his book, Outgrowing God. We are going to discuss more about fine-tuning and multiverse theory in the next session. The appeal to multiple universes is certainly one way of responding to evidence that seems to indicate design. The key question will be which interpretation of the facts is most plausible. I look forward to that. All right, that's it. Thank you all for your contributions today. By the way, I wonder if you, Hiromi, could prepare our introduction for next time, okay? Great. Hopefully we will have Astrid with us as well. Then we will finish for today. I'll switch off the recorder. You have been listening to The Question of God. Has our civilization outgrown God? A 12-episode podcast series from Biocosmos Norway and Damaris Norway. You can find references and resources online. The script by Birge Elliott Benson and Peter S. Williams was adapted from parts of the book Outgrowing God, A Beginner's Guide to Richard Dawkins, and The God Debate by Peter S. Williams, who also composed the music. All voices, including mine, were performed using AI. The sound editor was Birge Elliott Benson.